Welcome to another session. We have been solving exercise 1.3, the second problem. So prove that 3 plus root 25 is irrational. So by theorem of contradictions, I assume 3.2 root 5 is rational numbers. Okay. So for that I write 3.2 root 5 equals a by b, and the condition is a and b or co-primes, and b so b not equal 0. So this is the condition, and further I do so in the next step I take 2 root 5 the same place, and a by b I take 3 to the other side minus 3. So now take LCM b, so a minus 3b, right? So after this, root 5 equals a minus 3b by b, and 2, if 2 comes here the other side, so it goes division, right? So 2b, I write 2b. So see, look at this answer here. It proves root 5 is rational number, right? So what is rational number? It's in the format p by q. So actually this is in the format of p by q. So root 5, it shows root 5 is rational number, but actually it contradicts our problem. So we already know root 5 is not rational number. So now it contradicts our problem here. So root 5 is rational number, just we found out it contradicts our theorem. Root 5 is not rational number actually. So if once root 5 is not rational number, see that expressions 3 plus 2 root 5 is also not rational number. So now it contradicts our assumption. What we assumed here, 3 plus 2 root 5 is a rational number. This is what our assumption, right? But it contradicts our answer. 3 plus 2 root 5 is also not rational number, right? So this is how we prove that 3 plus 2 root 5 is irrational number using theorem of contradiction. So here is the next problem. Prove that the following are irrationals. So first one is 1 by root 2. So I take first problem. I assume 1 by 2 is a rational number equals a by b, right? Where a and b are co-primes, b not equals 0. Sorry, root 2. The next step. So here I write the reciprocal of 1 by 2 is root 2, right? Root 2 by 1. That means root 2. So here, so b by a. I take the reciprocal of this number. Then, so now what we have here, so b by a equals root 2. So b by a is an integer. Since integer, it can be rational value. But we know that root 2 is not rational number. We already found out. So it contradicts with our assumption, right? That 1 by 2 equals a by b we assumed, right? So here it contradicts our assumption. So root 1 by root 2 is not the rational numbers. So what are we doing with the theorem of contradiction? We just assumed opposite way and we prove that our assumption is wrong. Once our assumption is wrong, we able to find our problem is rational, our number is rational or irrational numbers, right? This is what we are doing with theorem of contradiction. So the same process we'll able to do with 7 root 5 and the 6 plus root 5. You can follow the same procedure I done before, right? This one, 3 plus 2 root 5. Look at this both are same format, right? They both have same format, so you can try solving 6 plus root 2 in this way, like we did for 3 plus 2 root 5. So hope you understand. Thank you.